Now we are discussing a chapter. Its name is waves. The title of this chapter is wave. What is the meaning of a wave? Before going to discuss its detailed analysis, the definition of wave we can say like this. In childhood we have played many games. So the one of the famous game is throwing the stones into a calm or steady pond or river. Let us suppose the water, we have different locations of water, different resources of water. It was steady, calm. So it may be a river or ponds. Suddenly we have dropped a stone at one point. Where we have dropped the stone is nothing but the origin of the wave. And in our general words we used to say this was as point of disturbance. This disturbance was uniformly distributed over a volume on the surface of water in a circular wave. Like this, uniformly distributed. That means whenever the disturbance was created at one point in a steady river or steady pond, and this disturbance is distributed over the entire volume of the surface of the water through up to some limited range, then we can say that the carrying the disturbance along with the energy or the transfer of energy towards the different points from a common position is called wave. So a wave can carry the information in a form of energy. Carrying the information towards long distances or carrying the energy towards long distances is called a wave. We are not discussing the propagation of the waves and parameters related to the wave. We are just defining a common nature of the wave. So it carries the information, it carries the disturbance towards the longer regions, and it carries some energy also. The stone which was dropped, it is creating the force, a disturbed force converts to energy and passing over a volume. And when we see a cork, a rubber cork which is made up of a rubber material, while it is oscillating on the float of water like this. Suppose this is a rubber cork. When it is oscillating, it is tilting like this, means moves up and down. Some part will be down, some part will be up like this. When it is doing this up and down oscillatory motion, this disturbance also can be created at that point of up and down, and it will be distributed over the entire volume. Here also we can say that the disturbance was carried to the longer distances. So this is the general view of the wave. These waves are two types. One is mechanical wave, second one is electromagnetic wave. So in this lesson, we used to discuss about the mechanical wave. So before going to discussion of the mechanical wave, we should discuss about the classification of the waves on the basis of propagation. Now we will see the classification of waves, nothing but the types of waves. So we can say that wave is the transfer of energy from one point to another point. So wave is defined as the transfer of energy from one point to another point. These waves are of two types. One is mechanical wave. Mechanical. What is the meaning of mechanical? In case of Newton's laws, we have discussed about mechanical force. Means if a force was applied by a human being to move an object, to change the shape of an object, to change the direction of an object, these all forces are under the mechanical forces. So the mechanical wave means the waves which were produced by machines, the waves which were produced by the human beings, the waves, best example a sound wave, these all under the mechanical waves. These mechanical waves are defined like this. If a wave requires a material medium to propagate from one point to another point, those waves are called as mechanical waves. So if a wave requires a material medium to propagate from one point to another point, those are called mechanical waves. So what we can see the examples in this case. Suppose this is the board. Suppose I am applying some force on the board. So simply a sound is coming out of this. Means I am applying my mechanical force at one point on the board, and the disturbance was created in this board, in this solid body, and this disturbance is coming out in a form of sound energy or sound wave. So if I am pushing a body, pulling a body, I am throwing a ball, these all are the mechanical expressions of the wave. So what we can understand is the mechanical waves requires a material medium. What are the material medium we have to propagate? Air is a medium, liquids are the medium, solids are the medium. So this is the materials we have to propagate the sound. That means these waves need a medium, are dependent on medium to propagate. The best examples are sound waves, the crest and trough. We can observe the tidal waves in the ocean, tidal waves. So these all may be a sound wave which is created through a mechanical rod or a machinery rod, the bus horn, train horns, these all are the mechanical waves. So we can say many big list of these examples. So the maximum velocity of these mechanical waves in air is 340 meters per second. Such like this, we can experience the mechanical waves in our daily life. The next classification in the category is longitude transverse waves. So the next classification in the types of waves is transverse wave. This transverse wave is also called as electromagnetic wave. So what is the electromagnetic wave? In the previous case, we used to compare this one in transverse wave, but we can say that electromagnetic waves are such type of transverse wave. But all transverse waves are not electromagnetic waves. There are many sound waves which are transverse in nature. So it is a type of transverse wave in the subclassification of the waves. So electromagnetic waves means these waves doesn't require any medium to propagate, and they can travel through vacuum also. So if the waves are not required of a material medium and can pass through the vacuum are called electromagnetic waves. So these electromagnetic waves doesn't require any medium to propagate. They can travel through vacuum also. What are the best examples of these electromagnetic waves? Light rays, X-rays, gamma rays, beta rays, alpha rays, all the radiations that are ejected from the black bodies or the radioactive bodies, and infrared rays. These all are under the examples of electromagnetic waves. Most of this electromagnetic radiation contains in the sunlight only. So sunlight is classified into two types. One is visible light and another one is invisible light. So the invisible light to the visible light we can classify as electromagnetic spectrum. So in this case what we can understand is these all rays that can travel with the speed of light, that is nothing but 3 into 10 to the power of 8 meters per second, which is very high when compared to any other waves or any other energy sources. So they can travel through vacuum. Best example, sunlight, the distance from sun to earth is approximately 1.5 into 10 to the power of 11 meters. Still 2/3 of it is filled with vacuum. Still we are experiencing the sunlight on the earth. This way we can prove that the sunlight are the electromagnetic waves that can travel through vacuum also. Now we should clearly discuss about the mechanical waves and their propagation and the characteristics that are associated with the mechanical wave propagation. Now we will discuss about the mechanical waves. These mechanical waves are defined as it is such a transfer of energy from one point to the another point that is produced by the repeated periodic motion of the particles of the medium about their mean position. So this is called a mechanical wave. If you want to produce the mechanical wave, we should need a medium. This medium is called elastic medium. Otherwise, the particles of the medium doesn't propagate or doesn't repeat the oscillatory motion. So it is a type of transfer of energy from one point to another point due to the repeated motion of particles of the medium about their mean position. To produce these type of waves, we need an elastic medium. So what are the characteristics of the elastic medium? Yes, they have the compressibility, they have the property of expansion also, so we can say the expansion and compression is in the regular orders of intervals or alternative order. So these are the characteristics of the elastic medium. So elastic in nature, if a medium possesses these type of characteristics, we can say that one as elastic medium. So what are the examples of the mechanical waves at different parts we can observe? The first one is waves on water surface. Second one is waves on ropes or strings. Now we will discuss these two examples under the case of mechanical waves with examples. So one of the example in the mechanical waves is waves on water surface. So the waves on water surface means, as we discussed previously, so this is the water surface. If it is the dimensions of the water, maybe it is a river or pond. Water is located like this. Whenever a point of disturbance due to a stone, due to any object was created at any point of these dimensions of the river or pond, then it creates a circular loop around it up to some dimensions. Actually, it is appeared to be circular loops, but if you see, it is a continuous propagation of compression and rarefaction, or expansion or compression. So it is like this. So we can see the water wave propagating like that. So as it is going to decrease, as it is going to further, its amplitude is going to decrease and continuously like this. So this is the point of disturbance. On either ends, we can see the same propagation like this. So the intensity increasing and suddenly decreasing, again increasing, decreasing, again increasing, decreasing. So like this, we can say that it is the elastic behavior of the medium, which goes to the expansion as well as compression, repeatedly maintaining the regular time intervals. This is called elastic behavior of the medium. So when the point of disturbance is occurred, water behaves as an elastic medium, then we can observe these wave propagations on either ends. It seems to be the locus of all these wave propagations are seen to be circular loops around a common point. But we can see the crests and troughs or tidal waves like a tidal shape on the water surface. Same thing will happen on the ropes also. If it is a rope or thread, what we can understand from this rope or thread, suppose if a rope is connected at one end and free at another end. Suppose if you disturb this free end, then the wave propagation will be like this. Like this. And this crest which was formed at the point of disturbance, it will keep on moving along the length of the rope. So for the next one, this one will create like this. For the next level, it will be like this. Next, it will be like this. And automatically, it comes to rest. See, this crest which was formed at the point of disturbance is continuously moving towards the fixed end of the rope. So the force at one end and force at this end, these two creates the loop. So this is also a mechanical wave. It is also the elastic nature of the medium, which can expand and which can compress at regular time intervals by means of its mean position. This is also called a wave motion in the ropes or thread. Now we will discuss the different types of waves and their propagation with respect to its characteristics. Now we will discuss the different types of mechanical waves. These mechanical waves are again classified into two types. One is longitudinal wave. Yeah, in the title itself, it is a longitudinal, means lengthy. So what is this longitudinal waves? The particles of the medium moving back and forth along the propagation of the wave is called a longitudinal wave. That means in longitudinal waves, the particles of the medium moving back and forth about their mean position along the propagation of waves is called longitudinal. What are the examples of these longitudinal waves? Sound waves created in metal rods, and motion of the particles in an air column in an open tube, one end open tube. So the motion of the particles in an air column, the to and fro motion of the spring, these all are called as or subtitled as examples of longitudinal waves. And what is the characteristics of these longitudinal waves and how the air particles will behave in such cases we will discuss now. So this longitudinal wave mainly consists of two parts: compression, rarefaction. And rarefaction. So what we can understand from this compression or rarefaction? Let us try to assume a tuning fork which is of the Y shape. Like this. When I have beaten this tuning fork at one end, it used to vibrate about their mean position like this, away from the mean position and towards the mean position. So the air particles or the particles of the medium are moving away from the mean position or towards the mean position. These are the two cases. If suppose all the particles of the medium are moving away from their mean position, means the particles of the medium are moving away, means volume increases, density decreases. The volume of the air column increases, all are moving away. So that's why if volume increases, density decreases. So what we can say that if these all are moving away within a given over volume, So this is said to be a rarefaction. But what about the compression? When all the particles of the medium is propagating towards the mean position of the disturbance, then volume will be decreased and the particles will be surrounded closely like this. So more particles of the medium are crowded within a small given volume. That means its density is going to increase. That's why it is better to draw very close to close. So here to here, what is the difference? Here, more particles are crowded in the given volume. That means density increases, volume decreases, correspondingly density increases. Suppose if this is the given volume, we can approximately see some 10 to 12 particles in this volume. But here, more than 20 particles are there. Density increases because density is mass by volume, inversely proportional to the volume. Volume increases, density decreases, and vice versa. So this part is called compression. So what is the meaning of this? Rarefaction, expansion, similar to the expansion. So in case of expansion, volume increases, density decreases. But in case of compression, all the particles are moving towards the mean position. So more crowdness or crowded particles are more within a given volume of the interior. So this is called compression. The center of the two successive compressions or the center of the two successive rarefactions is called wavelength. So lambda is equal to the distance between the centers of two successive compressions or rarefactions is called wavelength. That means this is the compression, and again we will see n more rarefaction, then again compression. So we can observe the more crowded particles within the given volume like this. So we can immerse more points to fill the gaps. So this is compression. This is also compression. So this is rarefaction, this is rarefaction. So from centers of rarefaction to rarefaction is called lambda, or the centers of compression to compression is called lambda. Like this, we can represent the wavelength in terms of compression and rarefactions in case of longitudinal mechanical waves.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.